Hi, this is Lab 2 motion of a falling object by using Newton's second law of motion and the momentum principle. The momentum principle is equal to the delta p is equal to F net multiplied by delta t, and Newton's second law of motion is the final velocity is equal to initial velocity plus F net divided by mass multiplied by delta t. We can also predict the motion of an object by using this equation. The final position is equal to initial position plus velocity multiplied by delta t. Motion of a falling object, the main assumption is that F net is not equal to 0 due to main interaction from the surrounding on our system, that is the weight force and the drag force. We performed an experiment on a paper ball. Mass is 6 gram, which is equal to 0.006 kg. By using tracker, we collect a motion data. The whole session is 0.567 seconds and start from the frame 17 up to 34 frames. When we play it, we will see on the right of the tracker sheet that the ball will move in a curve. It means there is interaction from the surrounding on our system. The initial condition we use in a wave python, that is t is equal to 0, the initial velocity is equal to 0, and the vector position is equal to 0. By using VPython, we construct a computer model by putting the ball mass 0.006 kg, the ball position, the ball velocity, and here we see that F net is equal to the weight force plus the drag force. When we run the module, we will see that initially the ball, we have a yellow line which is the weight force, but as the ball gradually downward, there is a blue arrows which is the drag force. Initially the drag force is have a very small value. As the ball moves downward, the velocity increases, so the drag force is increasing. By using the Google sheet, we form a graph. What is the experiment, what's model? The blue represents the experimental position and the green represents the model position. They start from the origin, and there is a little difference between these two values. There is still some interaction from the surrounding on our system. What does it mean? Determinant velocity. Terminal velocity is equal to the sum of the drag forces and the down forces of the gravity. Here we see that the F net is equal to 0 and we have a constant velocity. In a wave python, we will see that we calculated that the drag force is equal to the weight force, which is equal to 0.058 Newton, and the value of V is 0.485 Newton second per meter. When we put these value in a VPython and we run it, we will see that the ball will move in a straight slope. This means that we have a constant velocity. What if the object was initially thrown downward? Would the terminal velocity in this case be the same or different from the cases where the same object was initially dropped from the rest? In first case, we see that the first computer model, we will see that the initial ball velocity is 0, but when we put some velocity value, we will see that and run the module, we will see that the ball have a drag force from the initial, and it goes on increasing when it goes downward. So we conclude that the determinant velocity is different for these two cases. If the ball is dropped either from the start, or the initial velocity is 0, or velocity have some values. So here it is the end of the lab 2 motion of falling object.